kids, Miss Kulkarni here. In this video, we are going to continue with reaction stoichiometry part 3. So what is so special about this unit? We will discuss mass, volume, liquids in the problems. So our roadmap which we talked about is extending. We already know from moles we can go to particles. From moles we can go either way to mass, and from moles we can also go to the volume of gas in liters. We are going to extend that grams in mass to milliliters, and we may be able to extend that further to liters or some other units if we wish to. So we are going to make use of density when we convert grams to milliliters. Let's actually begin our first problem. Okay, so in this problem there is bromine reacting with calcium iodide. Let's get the reaction balance, and bromine is liquid, so I want to make sure I write down that so I won't do the same mistake again. And then calcium iodide is CaI2, and then when both react your answer is calcium bromide and then iodine is free. Given to us is 400.0 grams of calcium iodide. Okay, now we are going to go as usual from grams to moles. Then we go to moles of bromine. And now from moles of bromine, our final destination has to be how many liters? But we cannot go directly from moles to liters. We go from moles to grams, then from grams to milliliter, and from milliliters to liters. So there are actually three parts here, and when we go from grams to milliliter, that's the part when we are going to make use of density. So let's write our big long journey roadmap. The beginning point is grams of calcium iodide, and that's 400.0 grams. Then we are going to go to moles here. So that's moles of calcium iodide. Then from moles of calcium iodide, next step is we are right over here, and that is moles of bromine. Moles of bromine. Then we go to grams of bromine. From grams we are going to go to milliliters of bromine. And from milliliters we are going to go to liters of bromine. Don't worry, even though it looks pretty long. So let's use our previous knowledge and complete all this roadmap, because we need to cancel each of that unit. So diagonally across, look what we have, and keep on writing exactly same thing. So over here it's grams of bromine, and then this is milliliters of bromine. Once when you got all this set up, use your previous knowledge again. It's moles to gram ratio. Mole is always number 1, and gram is the molar mass, which I believe I got 293.88 grams. Then this is the mole ratio for bromine and calcium iodide. And look over here, if there is no coefficient, that means it is 1. So for both bromine and calcium iodide, the mole ratio is actually 1 to 1. This is moles to grams. Mole is 1, and then I need to get molar mass for bromine. Remember, bromine is diatomic, so it is 2 times the atomic mass, which is 159.8 grams. And over here this is grams to milliliter, and I want you to be careful because we are making use of density here, which is 3.12 grams per milliliter. That means for 1 milliliter. Look what we have here. This is grams per milliliter, and the ratio is 3.12 to 1. We are only flipping that ratio over here, so I can say this is 3.12 and this is 1 milliliter. And then over here this is milli going to liters, and you know the basic unit is 1, and with liters we put 10 to the negative 3, and then it's simply we have to cancel the units, and then there we go. We are going to get the answer finally for liters of bromine, which I believe I got as 0.069 7 liters. Alright, are you ready for the next problem? So in this question, we have hydrogen gas reacting with liquid bromine and producing hydrogen bromide. Let's get the reaction first. And keep in mind, it says liquid bromine. And then that is giving HBr, that's balancing, and also hydrogen gas is gas at STP. So your beginning point is 40.0 milliliters of bromine, and your end point should be how many liters of hydrogen we have. It is not simply converting milliliters to directly mole. We need to use density. Anytime there is liquid, we are going to make use of density. From milliliters, we are going to go to grams using density value. From grams, we are going to go to moles, and then from moles of bromine, we can go to moles of hydrogen, and from there, it will be liters of hydrogen. So let's see, when we put all these things together, how does it look? That is 40.0 milliliters of bromine, which is liquid. The next thing is grams for bromine. The next part after that is going to be over here. The next part will be moles of bromine. The next thing will be moles of hydrogen, and from there we are going to go to liters of hydrogen. Once when you get the roadmap, it is simply crisscross cancelling. So just look across and cancel or write down those terms which are diagonally across exactly same as it appears in numerator. So that's moles of bromine, and this is moles of H2. Okay, this ratio is grams to milliliter, and look at density. Density value is 3.12 grams per milliliter. That means it's per 1 milliliter. So we are going to make use of that 3.12 grams per 1 milliliter here. This is moles to gram, which is mole is always number 1, and grams is the molar mass, which is 159.8 grams. This is mole to mole ratio, and what do we have? There is no number, no coefficient, which means it's actually 1. So the mole ratio is 1 to 1, and this is moles to liters. Since hydrogen is gas and at STP, we can complete that with 22.4 liters. When all these things are filled in, you can cancel all the units, and then what is left over is liters of hydrogen. So simply multiply all the values, numbers in numerator, divide by denominator, and what do we get the answer? The answer is 17.5 liters of hydrogen. So don't you think it was easy? Okay, I'll see you next video. Bye.